Hello, ladies and gentlemen. I'm Adarsh. I'm a project manager at Perceptive Analytics, and I also have with me Chaitanya, CEO of Perceptive Analytics. We extend a warm welcome to all of you for our webinar, Building Robust Financial Models. Chaitanya would be taking you all through the webinar. To introduce Chaitanya briefly, he has a total experience of 15 years, and he has served more than 300 clients from around the world. He is a chartered accountant, which is equivalent to CPA in the US, and he has an MBA from Indian School of Business. The clientele serviced by Chaitanya include a wide range of companies, some listed in Silicon Valley, consumer packaged goods and retail companies, and some oil companies. So now I hand over the mic to Chaitanya.
Thank you, Adarsh. Ladies and gentlemen, good morning, good afternoon, good evening, wherever you have joined us from. Thank you very much for joining us today for this webinar on building robust financial models. Just to tell you a little bit about Perceptive Analytics, you are a data analytics company, and Spreadsheet Solutions is also part of what we offer. We are located in New York, San Bruno, Boston, and Hyderabad, India, 4 locations, and predominantly offering a lot of financial modeling is very much part of our services that we offer. We essentially do either various types of valuation models or specific decision support tools. In some cases, it could also be modeling in the form of spreadsheet applications. So far as data analytics is concerned, we specialize in data visualizations and also data analytics, specifically focusing on marketing analytics. Some of the verticals that we focus on are consumer packaged goods, retail, and healthcare. Let me quickly walk you through a few case studies specifically on financial modeling, and then we'll get into the actual topic. Let me also quickly mention that today we would be, this webinar will be roughly about 40 to 45 minutes depending on the questions. First, this is the model that you can see on the screen. Is a dashboard of a financial model that we have built. This was built for a Silicon Valley startup. The company was very keen to understand its cash position to see where the company is going and whether all of its strategies are sort of bearing fruit, whether each of the pieces of the organization is going to behave the way it thinks or it wants it to be, and what the end result is going to be. So if you look at it here, so because the company is a startup and cash is the most important asset they want to guard, so you have the cash position right on the top, and you have the actuals and the forecast separated out, and you can also see sales picking up slowly. And what you have here is the red bars indicate its cash outflow, and over time it becomes cash inflow. You also have the average selling price here and their brand strategy located below that, as the retail sales strategy retail channel keeps picking up, which is more profitable and something that they get more higher average selling price. The average selling price can actually is ticking up here. It also has net margin. Net, this is underneath this is a financial model. I will show you a sample of a financial model in just a few minutes. But a dashboard like this would be a boardroom strategy discussion piece that will really help in pulling together all different pieces of the discussion to one place, and this can be a great storyboard. So the next one is a financial model to predict cash requirements. This was for a flight operations services provider based in the Middle East. So what you see here is, once again, underneath this is a financial model. In this case, it's a budget, And you can see here the companies wants to track revenue. So revenue is right on top, and you can see actual revenues, that is historical, versus we have projected revenues. And you also have net margin, so it shows what you are budgeting for. At the bottom, you also have budget versus actual, whether it is a larger variances in terms of dollars or in terms of top variances in terms of percentage. Both of them are shown. So this is the second example. Let's go on to the third one, which is this was done for an electronics company in New York. And so what we have done here is we have once again, there is a financial model underneath this, but we are showing dashboard because that is far easier for us to show, and something that can quickly make sense. So on the left hand side, you have variables like all the revenue management variables, like for example, when is the how much of your revenue is going to come in 1 month, 2 months, 3 months, and so on. If there's an early pay discount, and so on and so forth. So all the key assumptions are listed here. Something listed in yellow means that's a variable. And you have what if analysis in terms of revenue forecast, which is a key parameter in terms of how much cash you're going to require from a bank. So you'll be able to use these arrows to do what if analysis. And on the right hand side, you will have the credit requirement in terms of how much cash either the company is going to be left over with, or on the other hand, if the company has to borrow. If it has to borrow, it is in red. So the crux of this kind of a model is we want to know how deep is this red bar going to go, because that's the number the company would use to negotiate with the bank as to how much credit requirement it would need. You also have a couple of things like you can do a what if scenario analysis. You can if the company has cash balance, it can set up certain percentage of return so that the initial cash balance is sufficient to meet its current credit requirement, and so on. So let's move on. So if you have any questions throughout this webinar, just go ahead, use ask a question feature in GoToWebinar, and we will get to them at the end. So just don't wait. Whenever you have a question, just go ahead and shoot it. So a quick poll for you before we move on. Please let us know, which industry do you work in. I'm just going to quickly pull the poll up for you. I'll keep the poll on for another 3 seconds. Okay, perfect. So here are the results we have. So about 31% consulting, 38% others, 23% BFSI. So next question about which function do you work in? Okay, I'll keep the poll on for another 2 to 3 seconds. So here are the results. We have about 36% others and 21% from finance and accounts, research, and consulting. All right. So let me give you certain, what should I say, as to who the target audience is and what we felt the target audience, who the target audience were. So essentially, this this webinar is for those who have done substantial amount of financial and in general spreadsheet modeling, because a number of strategic long-term decisions are taken on spreadsheets, and that's the best way that is available today whenever it comes to quantitative modeling. Financial modeling specifically is relevant in these industries. So that's why this webinar is meant for private equity companies, investment bankers, venture capitalists, mergers and acquisitions professionals, and also those in larger companies evaluating strategic initiatives, and of course startups and finance professionals responsible for budgeting. These are the gamut of people that will find this webinar very useful because it is sort of meant for them. At the same time, I should also mention that if you do not have prior experience in modeling, you'll probably find what we are saying Greek and Latin, because you'll probably not be able to make head or tail of what we are saying, because certain amount of experience in modeling is essential before we can make sense out of this webinar. At the same time, the value that this webinar will add is that it will help you make models robust, will make you and your work more reliable in your organization, and will help you make much better decisions because you're able to put together an awesome spreadsheet model. A quick overview. We'll talk about what is the need for best practices, and we'll go over each of the steps of stages of modeling life cycle, and we will talk about how to make your model robust and deliver much better model. At the same time, let me also quickly give you an overview of one financial model. So if you have not handled financial models before, you have a quick overview of it. So I'm just going to quickly shift gears. So here is a financial model that we have built recently, and obviously the numbers here are all placeholder numbers. But let me just walk you through. If you look at the bottom, you can see that there are various sheets here. You have assumptions, you have revenue, costs, hiring, fixed assets, scenarios, right? Investor-related information, loans, and then outputs, which is income statement, balance sheet, cash flow, and there is a dashboard and so on and so forth. So let me just walk you through each of these and tell you what it contains. So assumptions contain key assumptions that are related to the entire financial model. It can be revenue assumptions or cost assumptions. So for example, it has some of the revenue assumptions here, and the rest of them are cost assumptions. There are also generic assumptions like inflation and so on. So far as revenue is concerned, so this particular company has several lines of businesses and revenue sources. For each of them, you have a model here. Similarly, various kinds of costs, and then salary costs right here. And you have fixed assets with depreciation. You have scenarios, which would be, base case, most likely, and worst case, and you'll be able to select, whichever case you would like to choose right here. And there is information about a certain number of investors and how much their contribution is to the company. Let me just go over to the income statement. As you can see, this is income statement, and at the bottom you have income statement on an yearly basis. Similarly, you have a balance sheet right here, and you have balance sheet on an yearly basis at the bottom, and you have cash flow information as well. So let me quickly show you a dashboard information. So let me just quickly, this is a good example of a reasonable dashboard. We keep building awesome dashboards. So here essentially we show whatever is that company primarily tracking, and something that they would want to make decisions using this information. So in this case, the number of students, how the revenue split is, and what the total revenue and net income are going to be, and the cash flow are the key parameters, including return on investment. So these are the various parameters. So like I said, this is a good overview of a reasonable financial model. Let me quickly talk about why follow best practices, and then we would go into the rest of the webinar. So whenever when you have worked on any financial or other spreadsheet models, and you send it to someone, and they call you back and they tell you we haven't understood what is there in the model, so that is a pretty good indicator that following best practices will yield a lot of value to you. Let me give you a couple of other ones, other sort of symptoms. Whenever you uncover major flaws just before you're about to deliver it to the top management, or some key decisions are to be taken. So that is also a good indicator. Similarly, if you have abandoned complicated spreadsheets because you can no longer make it useful for you, that is also a good indicator. Similarly, people won't trust your model, or the model doesn't actually answer the questions that you're looking for. These are all the symptoms that would indicate that if you follow best practices, then you will be in a position to gain from the model. Obviously, the benefits are that you would save a lot of time, first of all, because you're not reworking on the model time and again, and you will be much more productive. I think it's just the corollary of what I said. And you'll also be able to focus on the most important issues and generate the insights that you're looking for. And also you and your work will become much more reliable to the folks around you. At the end of it, I think it will improve confidence on the work that you're doing. So if you want to create robust financial models, there are two things that we can do better. One is define the objectives and calculations much better, so that these are more like the traffic signals that you would use to mutually communicate, mutually understand what we are going to achieve and how we are going to achieve it, so that after you pass on the baton, so to say, the other person can understand what you have done and run with it. We can also design it much better. So so we are now going to, so this is the standard life cycle, and my colleague Adarsh will now speak to you about a few of the stages of the modeling life cycle and what are the best practices you can follow within that. I will come back at the end again. Thank you.
Thank you, Chaitanya. So as we see the modeling life cycle, there are 6 steps in modeling life cycle. Starting from scope, specify, design, build, test, and use. So in this slide, we try to answer the question of how much time to spend on each leg of the modeling life cycle. A major deviation from conventional method of modeling is that we recommend 30% of the time to be spent on specifications. We are also of the opinion that testing is a critical aspect of the financial modeling and recommend to spend 15 to 20% of the time testing the model. So coming to the first step of the modeling life cycle, which is scope. The scope of a model defines the objectives and boundaries of the model. This answers some of the fundamental questions like what should the model do or not do, what is the appropriate level of detail, complexity, what assumptions to make, where would we get the data required for the model from. So depending upon the choices we make, we have to estimate the time and resources required for building the model. So a model should have one or more clear objectives. Consider a startup looking for an investment funding. In such a case, the fundamental goal of the model would have to be the valuation of the business as close to reality as possible. Once this is established, further decision would have to be taken whether or not you need a dashboard or what if analysis. For example, in this case, we are forecasting the business, and then the valuation is the fundamental goal of the model here, and the period of the forecast can be either 5 years or 10 years. So that is a choice that you would have to make. Similarly here, what if analysis also is a choice that you would have to make. Moving on to the second leg of the modeling life cycle, which is specify. The specification process lays the foundation for the core of any spreadsheet. Specifying the logic and use of underlying formulas to arrive at the results is the most important part of creation of any financial model. There are some benefits associated with this process, like addressing the most critical issues upfront. This also helps us in establishing a common understanding and also makes testing easier. The flow of information in any model is usually from inputs to calculations and then results. But in the specification process, this flow is reversed. Firstly, the model objectives drive the results. Then we determine the calculations necessary to arrive at the results and identify the requisite inputs for calculations. One of the good ways of having the specification process is through a bubble chart. A bubble diagram shows the logical flow of the model. In a bubble diagram, we can indicate the various intermediate steps in calculations before arriving at the end result. This example illustrates the different calculations and arrives at the model objective of calculating the profit. So here the different intermediate steps are calculation of revenue, calculation of the total cost, which is again a function of variable cost and fixed cost. So the advantages of these bubble charts is that they are quick and easy to draw, and user can control the level of detail, which is here you see that with the dotted lines it is represented that fixed cost can further be divided if the user wills. But the drawback of such a bubble chart is that they do not show calculations. Another form of specification is through a table. A calculation table consists of detailed statement of inputs and calculations in a model. Each item to be calculated has a description. This is followed by laying down all the cells that would be referenced for making the calculations. This is again followed by writing the formula as is and in English in the note section for easy understanding of the reader. The calculation tables are a rigorous way to find out how the model will work and are particularly useful when relationships are complex. However, the main drawback of such a table is that they consume a lot of time. Here in this example, we see that the calculation of a student's fee, registration fee, is being calculated. The different inputs that are going in here are input A, B, C, D, and E, where input A is just a flag. So in January 15, the company is starting its operations, and all the students who are newly joining the company would have to pay a registration fee, which is being checked by the number 1 here, so which is input A. And in the subsequent months, since these students would have already paid the registration fee, only the new students who are joining would have to pay the additional registration fee. So using this flag, the fee from the students enrolled is being calculated. So the same is being represented in a specification table where we are calling it as the calculation 4, which is the revenue from the registration fee. And the reference cells are all the cells which are part of the inputs, that is input A, B, C, D, and E, and this is the formula as is. And in the note section, we have the same formula written in English. So when this is shared to other stakeholders of the financial model, it would be very easy for them to understand. The next leg of the modeling life cycle is design. This is another important aspect of modeling, usually overlooked by the builders. A good design will make the model easy to understand, and as a result the modeler is less likely to make errors. This will also make it easy to hand over the model to someone else to maintain it, freeing up the time of the modeler. An important aspect of good design is to separate the inputs, calculations and results. This will avoid confusion when changing inputs to achieve a desired result. Also, there is general tendency to make inputs as part of the calculations. People also tend to have inputs hard-coded into the calculations. This should be avoided even if it is temporary last-minute change. So in this example here, you see that all the sheets that are marked in yellow have inputs in them, and the sheets marked in orange have calculations, and the sheets marked in green have results. So any changes that would have to be made to the model would have to be through the sheets marked in yellow. So using one formula per row helps in quicker development by allowing you to drag the formula across the row. This is also another important aspect of design. It makes it easy to test, update and maintain. Another aspect of design is always to refer to the left and to the top. Just like when you read a book from top to bottom and from left to right, it is recommended that the user always refer to the cells that are to the left. So this is because he would already have knowledge of these cells. This also brings transparency, as all assumptions built into the formulas immediately obvious to everyone viewing the sheet. So again, in an example here, we show that calculating the electricity charges for the month of July 14, we are referring to the cells that are to the left and to the top. This makes it very obvious that these numbers calculated here refer to July 14, and the inflationary effect is 1 here. So the other tips of design is to use multiple sheets. So this will make it easy to expand for repeatable blocks. For example, if you were to have information for various countries collected in the same format, you can have it for one country and replicate this sheet for other countries. And also use each column for the same purpose, which we will show in the next example. So in this example here, you see that in the income statement, in the column AA, we have May 14 as the reference month. So similarly, column AA also refers to the same month, May 14, in balance sheet also. So this should be maintained uniformly across all the sheets in the financial model. So the next tip of design is to have color coding. So this can be used to separate the sections of the model to be input by different departments, as we will see in the next example. And also, if possible, to have a version sheet where if different people are working on the version, then the versions can be recorded. So here we see that the costs of a company, if they were to be recorded by different departments, so the engineering department has been marked in blue, general and administrative in green, and customer service in orange. So when the financial model is shared with the different departments, they can be given instructions of making inputs only to the sections that pertain to them through the color coding. So, moving on to the next part of the modeling life cycles, now I hand over the mic to Chaitanya.
Thank you, Adarsh. So the next stage of model building is actually to build the model. So the issue with most of the modeling projects, in some of the cases, the clients that I have worked with, very few of them though, before we actually complete the previous steps, they would ask, hey, let's not waste our time doing all this discussion, let's go build the model. Now the question is, how do you build the model without actually knowing it? You may have the best mason, but unless you have the plan, you can't go ahead and build the model. So very often we have seen that the first few steps are actually not given adequate attention that those steps need. If you don't give attention to each of those steps before, it would result in people coming back with questions and additions in terms of assumptions at the final stage of the model, and it will also develop complications because we'll have to rework, and that will lead to lower productivity and so on and so forth. So all the steps that we have done until now are very important, and after this I have a few tips in terms of how you could build better. For you to be able to communicate very well, it is important for you to keep formulae simple, because formulas can get very complicated, specifically in the revenue section, where if you have, or in the case of some of the costs as well, if you have, let's say, in these days, for example, you have internet based companies that come up with a product, and you have revenue which has a certain amount of virality, and you want to be able to advertise, get some customers, and then you want to build in certain amount of virality. They will be in the system for some time and then go, and all of this needs modeling and can get very complicated. So in situations like that, formulas tends to be extremely long-winded. An example I have shown you right here. It's very difficult for anyone to understand what exactly is this person trying to do here. So if you have a situation like this, then you would rather want to break up those formulas into smaller thought chunks, so to say, so that you can handle it and wrap your mind around it very quickly. A few other examples would be use formulas like SUMIF or VLOOKUP or some product that will minimize the number on the length of the formula, so that you can keep it simple and you can communicate using that effectively. We have also seen that in many cases there are array formulas that could minimize the amount of space, spreadsheet space that is required, as well as minimize the complex calculations using array formulas. These would be useful only in certain types of calculations, but I would recommend you check them out. Also, using named ranges simplifies many formulas. An example, a simple example of that actually is right here. If you have equal sum D5 to Z5 minus sum of D25 to Z25, if you may want to specify that this way, which is equal sum of sales minus sum of cost. That makes it so much simpler to understand and much faster to understand as well. So using named ranges effectively is extremely critical for you to be able to build a good financial model. The next one I think is build error traps. Let me just try and explain what we mean here. So you have a net profit as per income statement budgeted as a row, and you have net profit as per budget versus calculations. It so happens that in this model, these two are supposed to be equal. So what we do here is that for each of the months, you would actually take the delta right here, and you would do that for all of the columns. If the model is built for 5 years, so then you have 60 such columns, and you would use this error trap to calculate all of the deltas between each of these rows for all the 60 months. So what this means is, even if there is 1 month in which there is a delta, this would show, I mean, this particular cell will show a number other than 0. So that will help you trap the error, and you can have a long list of those checks so that you can always come back to this sheet and then check if there are any errors, anywhere in the model. That would really help in minimizing those errors. You don't want your CFO to tell you somehow, let's say the balance sheet is not tallying, for example, and that's not a good thing at all. So error traps will help you trap those, and then you can fix them. Some of the safety features that are available in Excel, data validation, which is very widely used. If you have formulas like VLOOKUP, and if any of the users have to actually input something, it is better to give them a drop down so that the rest of the model works well. Similarly, if you are going to send the model to somebody who's not savvy with Excel, or for that matter, if you're going to send them to anybody, you might want to protect cells and make available just a few cells that they have to input for them to edit, so that people don't fundamentally alter the spreadsheet model that may have implications on the rest of the model. In general, in my experience, I have found that if you have to send it to any more than one person, it is better to actually protect the spreadsheet and send it so that it comes back intact with the information you need. So the last one is hide sheets. If you have a number of input sheets and calculation sheets, and some of the calculation sheets are not really relevant for your audience, it is better to just hide those sheets so that the clients or your target audience, your exec management, will not be bogged down by those sheets. They would just work like they're in black box. They don't have to see. I mean, it's a matter of judgment whether or not to hide calculation sheets, because if you're sending it to a CFO and if he wants to understand how the formula works, then he might get frustrated because sheets are hidden, and he or she has to now unhide them. But it's a matter of judgment. But in some cases, it is better to hide those excess sheets that are not really relevant for the purpose of discussion. So the last phase is really testing the model. So the first question here is, see, before you send out the model, before you ship the model, testing is the final phase. And the stronger you are at this stage, the greater is others' perception of how good a modeler you are, because you want to trap all of these issues at your end and make sure the model shows and seems and is robust. First question is when to test. So if you have a lot of time between the development of the model and the results, the CEO or CFO is actually busy with something else, they'll be back next month, then you have the luxury to be able to build it all, and then before it's used, you can thoroughly test the model. If you are working in an incremental way, then in that case it is better to let it complete until it is reasonably complete, or one complete sort of material sort of changes are made to the model so that the testing can come in. If you have to deliver immediately, then you'll have to figure out when exactly to test so that you can trade off between accurate result and reasonable results. One of the problems with testing also is that the more number of times you test, the more the more time you're going to spend really, because and it can make a big difference between if it is a client project, then the client may get frustrated that you're testing it too many times, or on the other hand, internally, so nobody really likes rework, right? In some way, if you have made some changes, you cannot partially test. That's a bit of a problem, because I have seen that if you only partially test, errors will lie where you have not tested. That is usually how it works. So so make sure you test it adequately, and if we follow the rest of the stages of the development, then you'll be in a position to minimize your testing effort. So here are a few tests. So I think this is a sort of a conceptual framework on how to test a model. The first is a specification test. So based on what others said, if you have a specification sheet, and it's very highly recommended to have one, so you can go through that and sort of check off each of the specification and make sure it works the way it's supposed to work. The second is the unique formula test. I think this is a very smart way of looking at how to audit a model, because let's assume we have seen in the previous case that if you have 5 years and the formula that you write in a month is exactly the same in each of the 60 columns, then it doesn't make any sense for us to test 60 columns, right? You'd rather test a unique formula. So there are commercial packages that are available that will show you what these unique formulae are, and then you can go and audit each of them. That will give you a pretty good a handle of the model. It will minimize your effort to test it. In addition, if there is any hard coding, then going through unique formulas, it would expose all the hard codings that was done in the model. So I think this is a very good way to look at testing a model. The next one is a numeric test, which is nothing but put in some numbers and check. And specifically, if there are two versions of the model and you have improved the previous one, you can compare numbers and check if they're giving the right numbers. Let's assume, let's say, 10 of the 6-page sheets that you have, 5 of them are exactly the same, and you worked on only on the other. And if all the assumptions are right, then the first 5 sheets should show exactly the same results as previously. Only the last one where you had worked on, only that should change. So check if that is exactly whether that is the way it's working or not. If there's any difference, you have a problem. There's also a robustness test, which is consider all feasible circumstances, and you actually stress test the model. You give either the lowest numbers or the highest numbers and check if it's working properly. If you have multiple stages, for example, then you might want to just test each of the stages separately and sort of blank the other stages out so that you exactly test that specific stage very well. So
Unmuted.
oh, it's not. I don't know what happened. So I think looks like there was some problem with the audio. I hope it is back now. Yep. All right, so let's move on. So here is one other testing tool that we have developed internally that will help us basically test the model as well as rely on the testing that is done by someone else. Let me just give you a small example. So here is one such. So what we do actually, let me just explain this a little bit more. So here, this is the testing document. So this is the PowerPoint presentation. So what we do is, as somebody tests a document, a financial model, then what we do is we, as we find issues, we capture the screenshot and put that in a PowerPoint presentation, and we annotate it. In this specific case, it says, okay, 5,000 after expiry date need to be fixed. You know, there seems to be an issue that the tester has understood. Somebody who prepared may have understood the issue as well. Now the question is, or what's the benefit of this? The benefit of this is that somebody who's reviewing the model, right, and the person both who has tested as well as the one fixing the model has complete information on what is the scenario and what are all the other assumptions that are used to be able to you know, come up with this hypothesis that there is something wrong, you know, that there's a bug. So this is very useful. So similarly, when somebody is reviewing, they can check all the various scenarios using which you know, the model has been tested. So what we recommend here is that you document not only the bugs that were noticed, but also wherever it has worked fine, that also has to be documented similarly, so that there is this ability to rely on someone else's testing. I find that very powerful in my reviews. So in the next version, you can make sure that the issue is fixed. So here is another example of a sample of some of the issues that were found. This is another thing that we have discovered internally, and something that we use is that we use checklists, and these checklists are extremely powerful because this gives you all the various things that you need to test without having to think about it. So you can, you know, look at functionality, look and feel, and so on and so forth. Let me just show that to you. So you have, from a functionality point of view, the functionality, look and feel, and then you have navigation, accessibility, printing, data validation, security, compatibility, you know, and so on and so forth. And from a code perspective, if there is VBA involved, then, you know, all the various things, including error handling and everything, is right here. Whether or not, if something is not applicable, you can always check off that it's not applicable and move on. So this is sort of, this helps you rely not just on somebody's memory, but you can document it and make sure that it is work. I mean, all these checks are done by everyone in the organization. So I think that is about it for now. So we have a Q&A right now, and I think we already have some good questions coming up. So if you have any other questions, this is a great time for you to ask those questions. So first question is from Mikhail Stwivelman. And the question is this: for accuracy of the growth rate, or WACC, which is weighted average cost of capital, what is the most sufficient time frame for forecasting? I think this is an awesome question. I think let me just try and you know, let me just try and tell you why this question is important. So in any financial model, the assumption on growth rate and the assumption of weighted average cost of capital are two assumptions that swing the valuation up or down. So these two assumptions are extremely critical. So once again, that's a great question, Mikhail. So see, I really feel that you know, for you to be able to you know, get to the right time frame, it is important to understand what business is that model really into, that company really into? Because so the answer is, whether a time frame is sufficient or not depends on a few factors, including the business, because there are businesses that spring up and wound up in a few years. So for such a business, if you actually have a really long time frame, that's not going to make sense, right? But on the other hand, take something like an oil refinery, that would last for about maybe 25 years or so. The product life cycle is not so small. So in those cases, you cannot have, let's say, 5 years time frame. It has to be much longer than that. So I think that is how I would like to answer this question. So the next question is from Imtiaz Ahmad. The question is, are you going to share the presentation and Excel with us? We would surely share the presentation and the video with you. We would be happy to do that. You can expect that to happen in the next few days. So we have another question also from Imtiaz Ahmad. The question is, what is the role and importance of Visual Basic in financial modeling? Should one also have the knowledge of C++? Okay. I'm not very sure where C++ comes into picture, but the role and importance of Visual Basic, Visual Basic may be relevant in some cases. Usually what I have seen is that models have their own life cycle, which means after it is done and you deliver it to your executive audience or your client, etc., so it goes through its own changes after that. So what Visual Basic does is to essentially automate some of the tasks, hopefully repetitive tasks, because that's what programming is all about. The problem with using Visual Basic is that after you use it, and if you have to make changes to the model, then you would have to basically rewrite the code, or the client or the executive management is not able to use the model because the code that you have written now, because the situation is different, messes up the model. So both the situations are not good. So the crux of what I'm saying, it's not that important. Where it is relevant, where it is really you feel it is relevant, you can use some of it so that you can automate some part of it. Otherwise, it's best not to use it. Yeah. So we have a few other questions coming up. Okay. So the question from Abhay Shah, I missed out the part on macro testing because of technical issue with audio. A little bit of light on that, please. Yes. So great. Thanks for asking, Abhay. I'm sure some of the others also missed that out. So what I was talking about so far as macro testing was that VBA has a very good testing environment. So you can go into that and use that to test your macros very well. Obviously, you'll have to think about what are the various branches, or what are the various scenarios that you would like to test the macro, and you'd have to essentially, this is like a programming testing in that sense. You'll have to feed it various assumptions and make sure that the output that it's supposed to give is what it has done. So I think that is about macro testing. Let me just see if there is anything else. So there is a question from Subhajit Gope. The question is, how is decision on assumptions taken while modeling? Is it a mutual process between two parties, or only the company decides that? I'm not sure about the later part of it. So the question is, how is the decision on assumptions taken while modeling? So good question. So essentially, I think the call really is, what are the various scenarios that I would like to test it, so that you can have an insightful model. And the other thing to also think about it is what are the inputs you're giving to the model, whether or not they change a lot. An example of this would be inflation, right? You would probably not change inflation a lot. You'll probably change it once or twice, because that's not unless your business is very, very reliant or sensitive to inflation, you would probably have it constant, and what the typical inflation in your economy of that business is. So in this case also, I think you would still have to give that as an assumption, because you don't want to be inputting that information 200 times in the model. If it can be just input once and same number is used multiple times, that's also a good way to look at what an input should be. But I think there is, let me just try and think of it from a different point of view. So when you give a model to somebody, what happens is as they enter all the information into the financial model first, their interaction with the model is going to be different from when after all the information is input, but they're just going to change some variables and do what-if analysis. So these two are different scenarios. So so in the first scenario, people would love to have all the assumptions in one sheet, but later on they would want it closer to where they want to make those decisions, when they want to do what-if analysis. So the way I think of it is, one is put some assumptions, very, very critical assumptions like pricing, etc., on the dashboard, so that folks can quickly make those, modify those assumptions and see what the model throws out. The second is any sort of assumptions like inflation, which are absolutely non-critical, tuck them away somewhere else, and where they are relevant for some of the calculations, check if you want to put them very close to where the calculations happen. So it's not just one straight answer, but I think this is something that you'll have to consider and take a decision on. Okay, so I think let me just check if there are any other questions. Okay, there's a question from Abhay Shah, which says, are there always two or more teams, one for model designing and the business side logic, and the other, say, the programming or the technical stuff? I mean, can there be a fusion of technical and decision-based responsibilities? Once again, a good question, Abhay. So, see, usually financial models are not, I think, let me put it like this, so models can be small to really, really large. So when they are really, really large, it doesn't involve 100 people, for example. It would involve maybe about 4 to 5 people. So because these are sort of questions that can be answered, and spreadsheet has its own limitations. It's not made so that hundreds of people can access it. It's just made so that a few people can access it. And the process also involves usually just a few people. So unless there is a real need to segregate programming and the business side logic, I usually see it done by just 1 or 2 people, or maybe 3 or 4 people at the best. But otherwise, I think that probably answers your question. There are usually just a few people who are working on the model, and very rarely do people segregate business side and the technical side. So let me just check if there is anyone else, any other question. Okay, I think that's it. We are done for today. Thank you very much, everyone who has attended this webinar. I really appreciate it. And we have a very small feedback survey. It would be great if you can just give us feedback that will help us modify and improve our webinar. I'm just going to launch it right now. So I'll keep the poll on for another 5 seconds. Right, I think we are done. So thank you very much, ladies and gentlemen. I really appreciate your time. I hope it was useful. If you have any other comments or questions, please feel free to email me. Here is my email ID, which is cs@perceptive-analytics.com. You also have my phone number. Once again, thank you very much, and thank you for joining. Appreciate it, and have a good day. Good night.